Hello students, today we are going to discuss about the chapter 2, that is polynomials. So first let us see what is polynomials. It is an expression of one or more algebraic terms, especially the sum of several terms that contain different powers of the same variable. So here we'll discuss about the polynomials of one variable. So this is one general polynomial. You can see px equals to a plus bx plus cx square plus dx cube and so on. Now here the important things that we need to note is the exponent of the variable of a polynomial must be a whole number. It means we can see this is the polynomial. Here the exponent of x, here it is 1, here it is 2, here it is 3, and even here also we have exponent, that is a into x to the power 0. So the exponent can be only whole numbers. Now let us take some examples. Here this is one polynomial. It is 2x plus 3. One more polynomial, 7x square minus 3x plus 3 by 2. Here we have one more polynomial. Now the number with the variables are known as coefficient. So here with x we have 2, this is called coefficient of x. Similarly here with x square we have 7, which is coefficient of x square. So here the coefficient of x is minus 3. So we must note that this number, this is called coefficient. Similarly here also this is coefficient. Here in this polynomial coefficient of x square is 5 by 2. Coefficient of x is minus 3. And coefficient of x cube is 8. And the last term, last number is constant. So here constant is minus 1. Here constant term is 3 by 2. Here constant term is 3. In the first polynomial, again 2x and 3 are one term of this polynomial. Similarly, in the second polynomial, 7x square is one term, minus 3x is one term, and 3 by 2 is another term. So each part is one term. Now, depending upon number of terms of a polynomial, it can be of different types. The types are monomials, binomials, trinomials, and so on. Now monomials means if the polynomial is having only one term, then it is a monomial. So for example, 7x is one monomial, 3 by 5 x to the power 20, this is another monomial, maybe this is another monomial, and so on. Similarly, binomials means the polynomials having only two terms is known as binomials. For example, 5x square plus 2x, this is one binomial. 7x cube minus 2, this can be another binomial. This can be also another binomial. Now similarly trinomials. The polynomials having only three terms are trinomials. So for example, 5x cube minus 2x plus 1. This can be one trinomial. We can see there are 3 terms. Then one more example, say minus 20x to the power 7 plus 2 by 3x minus 7. So this can also be one trinomial because there are 3 terms. Apart from this, if there are only numbers, then those are constant polynomials. Say for example 20. This is a number constant, but this can also be one polynomial and we call it as constant polynomial. Or maybe minus 37, or it can be one fraction also, 2 by 5. So these are all constant polynomial. Now next we have one more polynomial which is called zero polynomial. The number 0 itself is called the zero polynomial. Next, let us see the degree of a polynomial. So what is the degree of a polynomial? The highest power of the variable in a polynomial is known as the degree of the polynomial. So to explain this, let us take these examples. Here highest power or exponent x to the power 7, x to the power 5, 7. So if we see the highest power of x is 7. So here degree will be 7. Next, similarly, in this polynomial having variable y, if we see the highest power, here it is 3, here it is 4, here it is 9. So highest power is 9, then degree will be 9 here. Similarly, in the third polynomial, we can see 7x to the power 200 plus 5x to the power 90 minus x to the power 402 plus 750. So here, if we compare, the highest power is 402. So the degree will be 402. Now come to the fourth example. Here it is only 5. So what about the degree? So actually the degree of this constant polynomial, this is called constant polynomial, and degree of this constant polynomial is 0. Now we may ask why it is 0? Because 5 we can write it as 5 into any variable, say x to the power 0. So the highest exponent or highest power is 0. So that is why the degree of constant polynomial is always 0. Depending upon degree of a polynomial, again they have different classifications, and those are linear polynomial, quadratic polynomial, cubic polynomial, and so on. If the degree of a polynomial is only 1, then this is called linear polynomial. Then similarly, if the degree of polynomial is 2, then this is called quadratic polynomial. Quadratic means 2. And if the degree of the polynomial is 3, then we call it as cubic polynomial. And let us see some examples. Here you can see 5x plus 2, the highest power of x is 1, so degree of this polynomial is 1 and we call it as linear polynomial. Similarly, if we see this polynomial, the highest power of the variable is 2, so we'll call this as quadratic polynomial as the degree is 2. Then again, one polynomial of degree 3, 5x cube plus 2, the highest power of the variable is 3, so degree is 3. That means this is one example of a cubic polynomial. Looking at the definitions of polynomials, here we have one question where we have to identify that these expressions are polynomials or not. So if we see the first expression is given px equal to x square minus 1 by x plus 2. So obviously this is not a polynomial, because as we know, if the exponent of the variable is whole number, then only the expression can be a polynomial. But here 1 by x means the exponent or power of x is minus 1. If we write it as standard form, then it is x square minus x to the power minus 1 and plus 2. So this is not a whole number, so that is why this is not a polynomial. So we have written as the exponent of x is minus 1, so it is not a polynomial. Now let us come to the second expression. It is root over x plus 5x minus 1. Now here also, if we write this in standard form, we know root over x means x to the power 1 by 2, which is again not a whole number. That is why this expression is also not a polynomial. As you can see here this is 1 by 2, which is not a whole number. Now come to the third example. Fy equal to y to the power 11 minus 3y square plus 1 by 4. So if we see the variable y to the power 11 y square, so all are whole number, so it can be a polynomial. Though here constant is below 1 by 4, we might think that this is not a polynomial if we compare with this, but here you must see that x is variable and here 4 is constant. So we'll have to see only about the exponent of the variable. So this can be a polynomial. Similarly, the fourth example, 6y square minus 2y plus root 5. So here also the exponent of y is whole number, it is 2, it is 1. Though here also 5 has root over, but as the previous example, constant can have root over or it can be in denominator also, it doesn't matter. We have to see only the variable, that means the exponent of the variable, and they must be whole number, and that is why these two can be polynomial. So in today's class we have learned about polynomial and its definition along with different examples of polynomials. Here each part is known as one term and the number with variable is called coefficient and the alone number is constant. Then we have learned about the classifications, which are monomial, binomial, trinomials, and these are the divisions depending upon the number of terms of a polynomial. If there is only one term, then it is monomial. If there are two terms, then binomials. If there are three terms, then it is trinomials. Then we have learned about constant polynomial. If there is only one constant, say 20 or minus 37, these are constant polynomials. Then constant polynomial which is 0 is called zero polynomials. Next we have learned about degree of a polynomial. The highest exponent of the polynomial is degree. So here we have discussed about some examples. Then depending upon the degrees of a polynomial, it can be linear polynomial or quadratic polynomial or cubic polynomial and so on. Now if the degree is 1, then it is linear, degree 2 means it is quadratic polynomial, degree 3 means it is cubic polynomial. And finally we have discussed about some expressions which might not be a polynomial, as here the exponent is negative, here the exponent is fraction, so these are not polynomials. And this can be polynomials because the exponent of the variables are all whole numbers. Thank you.